Question 2 here. The diagram shows the displacement of waves time 0, blue, and time 0.5, red. What is the speed of the wave? Okay, think about it. Think about wavelength and how does it relate to the positions of the two waves. Determine the wavelength first. How long is the wavelength from this crest to the next crest here, right? So the wavelength is 1 meter. And the distance between the two waves, blue and red, is 2 division, which means 2 over 10 of 1 meter, meaning this is 0.2. The distance between the two crests of the two waves is 0.2 meter, which means it is 0.2 over 1 of a wavelength, the distance, okay? Meaning 1/5 of the wavelength. So the time 0.5 seconds here is 1/5 of the period. The time 0.5 seconds is 1/5 of the period. The waves moves by 1/5 wavelength. 1/5 of the wavelength. The period is 0.5 times 5, 2.5 seconds. And the wavelength is 1 meter. What is the speed of the wave? Okay, so we have the wavelength, 1 meter. The period is 5 times of 0.5, 2.5 seconds. The question is the speed of the wave. This wavelength is speed times period. So the speed is the wavelength divided by period, 1 over 0.25, 2.5, okay? 0.4, right? 0.4 meter per second. There's no answer. Yeah, that's a 6.
What's the time? What's the time 2.5?
The time 0.5 is the difference between the two waves, meaning the blue wave travel to the new position, the red wave, in 0.5 seconds. Okay? And that 0.5 seconds, the distance between these two crests is 0.2 meter, which is 1/5 of the wavelength. The wavelength is 1 meter. Okay? The distance it moved, yes, the distance it moved is 1/5 of the wavelength. It means the time 0.5 seconds here is 1/5 of the period. So answer is C, 0.4 meter per second.